Myself, JV and Dr. Kiran Yadav. In this session, I will discuss about the origin of quantum mechanics. So, this is the name of a book that is quite good. Its name is Quantum Mechanics Concepts and Application. Its author is Zetli. It is quite good for your MSc syllabus. You can prefer this book. The other book that you can prefer for your MSc syllabus are Satya Prakash, Quantum Mechanics by Satya Prakash and Quantum Mechanics by David J. Griffith. So, Quantum Mechanics by Satya Prakash is relatively easy and you can start from that book, and later on you can refer this Quantum Mechanics by David J. Griffith and Jet Li. So, let's start today's session. So, these are some of the famous scientists that contributed in the origin of quantum mechanics. The name of these scientists are Dirac, Planck, Hertz, Feynman, Heisenberg, Schrödinger, Bohr, Compton, and de Broglie. So these are also the scientists who contributed in the origin of quantum physics. So up to the end of 19th century, that means around 1885, there were three major branches of physics. First one was the classical mechanics, second one was the electromagnetic theory, and third one was the thermodynamics. In classical mechanics, dynamics of material bodies were studied. In electromagnetic theory, radiations were studied. Matter in terms of particle and radiation in waves were also studied. In thermodynamics, interaction between matter and radiations were studied, and the ultimate goal of studying physics was description of nature, or to describe how the various phenomena occur in nature. In the beginning of 20th century, classical physics seriously challenged on two major fronts. The validity of classical physics ceased at very high speeds and at microscopic level. So, in case of very high speeds, that means when the velocity of particle is of the order of velocity of light. In that case, we call it relativistic domain. So, in relativistic domain, Einstein's 1905 theory of relativity showed that the validity of Newton mechanics ceases in this domain. And at microscopic level, some newly discovered phenomena which deals with atomic and subatomic structures, the classical physics failed to explain those phenomena. So these two major failures of classical physics led to the origin of quantum physics, and that new concepts had to be invoked to describe, for instance, the structure of atoms and molecules and how light interacts with them. So basically, classical physics failed to explain microscopic phenomena like blackbody radiation, photoelectric effect, Compton scattering, atomic stability, atomic spectroscopy. So the quantum theory was given by Max Planck in 1900. In 1900, Max Planck gave a theory which served as the basis of quantum theory. He said that energy exchange between radiations and its surrounding take place in discrete amounts, or we can say that energy is quantized. Energy cannot have continuous values. There are only certain specific values that energy can have. Energy exchange between an electromagnetic wave of frequency nu and matter occurs only in integer multiples of h nu. The formula for energy was given as nh nu, where h is Planck's constant, nu is the frequency, and n is an integer. It can take values as 1, 2, 3, 4, etc. So Planck's quantum theory provided an accurate explanation of blackbody radiation and photoelectric effect also. Theoretical support was given by Einstein in 1905 about this theory, where he discussed quantization of EM wave, which is valid for light also. Light is itself made up of discrete bits of energy called photons, each of energy h nu, where nu is frequency of light. So the atomic, some other studies that contributed to the development of quantum physics are the discovery of atomic nucleus in 1911 by Rutherford. There is a famous experiment of Rutherford called alpha particle scattering, in which he took a gold foil which was very thin and he bombarded it with alpha particles, and in this experiment he discovered that there is a nucleus at the center of the atom. So another study was Bohr's model of the hydrogen atom, which was given in 1913. According to this Bohr's model, atoms can only be found in discrete states of energy. An interaction of atoms with radiation, that is the emission or absorption of radiation by atoms, takes place only in discrete amounts of energy. This led to explanation of atomic stability and atomic spectroscopy. In 1923, Compton scattering confirmed for the corpuscular aspect of light. The work by Planck, Einstein, Bohr, and Compton gave both the theoretical foundations as well as the conclusive experimental confirmation for the particle aspect of waves. Waves exhibit particle behavior at the microscopic scale. At this scale, classical physics fails not only quantitatively but even qualitatively and conceptually. T. Broglie in 1923 not only does radiation exhibit particle-like behavior, but conversely, material particles themselves display wave-like behavior. This was confirmed experimentally in 1927 by Davison and Zermer. Postulate of Planck and assumption of Bohr lack the ingredients of a theory. So by 1925, validate the various experimental findings as well as Bohr's postulate into a refined theory which is known as quantum mechanics or old quantum physics, and it provided an accurate reproduction of the existing experimental data. The theory turned out to explore and unravel many uncharted areas of the microphysical world. By microphysical world, we deal with the world that consists of very small particles like electrons, atoms, molecules, etc. So that's all for this session. If you have any doubts, you can mention in the comment section. I will respond there, or you can ask them during the live session or your live classes. So thank you, students. See you in next session.